So we will do 3 examples here as well. And out of these 3 sets of examples, you'll probably find that finding the angle is the easiest one of those 3. But to figure out again which one we want to use, which ratio we need to be using, we will write down the acronym SOH. First is making sure that we have a right triangle, which we do, and that means that we have a hypotenuse right there. That is given to us, so we'll put a check mark through those hypotenuses. Now we will look at the angle, and the angle is what we're looking for, so that means we will put a check mark through the ratios, because if we have a ratio, then we can use our calculator to turn that into an angle. And from the perspective of the angle, we have this side given to us, which is the opposite side. And so you can tell already that we need to use the sine ratio. And now we will insert the numbers that we are given. We don't have the angle, so we will just keep this as sine theta. It is called theta, so we will leave it as theta. The opposite is 4. That's the opposite to the angle. And the hypotenuse is 6. So we have 4 divided by 6. And now all you need to do is find out what this ratio is equal to on the right-hand side. So that's 4 divided by 6. And if you want to, you can write that down. That is 0.6667 if you keep 4 decimal places. But you want to change that into an angle. And remember from the first part of our lesson that to get from a ratio to an angle, I just have to use the inverse sine button. And so I have this ratio given to me already, that is 0.6 repeating. And to find out what the angle is, I will need to use the inverse sine button. So I can write it down like the inverse sine of 0.6667. And that will give me the angle of 41.8103. So the sine theta is 4 divided by 6, which means the sine of theta is 0.6667. And to get from this ratio to the angle, I just have to use the inverse sine button. And then it gives me the angle, which is 41.8103 degrees. And so that's all you need to do in this question. First, you know that you have to use the opposite and the hypotenuse. That means you need to use the sine ratio. So 4 divided by 6 will give you the sine ratio. But you want to go from the ratio to the angle, which means you need to use the inverse sine button, and then you have the angle. Your calculator converts the ratio into the angle. And so that's why I'm saying that this will most likely be the easiest one, because you don't actually have to solve an equation. All you have to do is take those 2 numbers, divide them by each other, and then convert it into an angle. Let's look at the next example. Here we have the letter alpha, and that is representing our angle in this corner here. Using our acronym, we can figure out which one of these 3 ratios we need to use. Since we have a right angle, we can actually do this, and this would be the hypotenuse of that right angle. And you can see that we don't have it labeled to be found, and we don't have a number there. And so therefore we will not put a check mark in for the hypotenuses. But it's always important to make sure that your angle is actually a right angle. So the next step then, the angle itself. We are looking for it, so that means if we have a ratio, we can convert that ratio into an angle. From the perspective of the angle, you should see that the 11 here is the opposite side. And from the perspective of the angle, you should see that 6 is the attached side, which means we have the adjacent side. And there is the ratio that we will need to use. And so one thing that people get sometimes confused with is this side is adjacent and this side is adjacent. Which one of those two sides should I be using? And remember, the adjacent side is always the one that is attached to the angle, which is not the hypotenuse. And that's why it's very important to always identify which one of your sides is the hypotenuse first. And so you can start with the ratio. Tan theta is equal to opposite divided by the adjacent. And now I will replace those values with what is given to me here. So the tan of the angle, and the angle is called alpha in this case, is equal to the opposite, which is 11, divided by the adjacent, which is 6. Find out what the ratio is, and then convert it into an angle. So I find out what the ratio is, and then I convert it into the angle. And let's do one last one. Checking to see if we do have a hypotenuse, which means do we have a right angle actually, and we do. And so therefore this has to be the hypotenuse. And so we are actually given what that hypotenuse is, so we can put a check mark through that. Next is the angle. Which angle am I looking for here? And if you look at this letter, you can see that this corner is labeled C, which means we are looking for this corner right here, the angle of that corner. Okay? So that means once I have the ratio, I can find out the angle. From the perspective of this angle now, we have this side here. And from the perspective of that angle, this side, it would be the adjacent side. So I have the adjacent, so I'll put a check mark through all the A's. That leaves me with using the cosine. And I'll set that up with the equation first. And now I will replace these with the values that are given to me. So the angle is called C. The adjacent is 14.3. And the hypotenuse is 21.5. And now all I need to do is find out what this ratio is and then use the inverse cos button to calculate the angle. So there's that ratio, 14.3 divided by 21.5. That's my cosine ratio, but I want to find the angle, which means I will use the inverse cos button to find out what the angle is equal to. And that is 48.3088. So now you are able to find out what the angle is. You're able to find out what the numerator is and what the denominator is equal to. In other words, you can solve any questions that have these trig ratios. A few notes at the end: make sure that you have a right triangle. And remember, you can also find the missing length using the Pythagorean theorem. So if you have two lengths given to you and you find out a third length, you can use the Pythagorean theorem. And the third thing is that all angles inside of a triangle have to add up to 180 degrees.